Hi, everybody. It's nice to see everyone. I hope everybody had a good evening. Friends, our conference was laid out so that you'll notice a movement, a kind of movement from the theoretical to the practical as we go along. It's important to know that our practice and our pastoral approaches are founded in theory that's solid. And so it's important to have that theoretical foundation laid out and the questions associated with it. It's also important to begin to make connections to our pastoral work. And as we go along, I think you'll see that the papers will have still a very theoretical balance, but as we go along, more and more of a self-conscious opening to practical questions. Until by the end of the conference, it should be the reverse emphasis. Also, our feedback from the last conference that we ran was that the schedule was a little too tightly packed without enough time for discussion and interchange. So what we've tried to do this time is open that up a little bit. We have only 2 papers instead of 3 this morning. They're laid out in such a way that after the talk, there should be plenty of time for discussion and some give and take. I run quite a few conferences here from time to time, and that means that if I were to always skip class, I would be fired. And so I actually have class at 9:30, so I am going to slip out during Professor Barr's talk and leave the session in the able hands of Father Peter Ryan, who will then also introduce the next speaker, and I'll be back during that talk. My topic today is the Trinity, so I can't let the students just wander and to find their own way. Though I'd like to. No, I didn't say that. Friends, it's my pleasure to introduce our first speaker this morning. Stephen M. Barr is professor of physics at the University of Delaware. His research takes him from a focus on the most minute measurable phenomena, subatomic particles, to the grandest of measurable phenomena, the universe itself, hence cosmology, the history of the universe from its earliest moments, to the grand unified theories of the origin and character of the cosmos. It is easy to see how such research brings him to the interface of science, philosophy, and religion, for it is just at this interface that issues of appropriate disciplinary boundaries emerge. Where does science end and philosophy begin? What, in particular, might be the relationship between science and the discipline once and still called natural theology, which covers what can, at least in theory, be known about God on the basis of reason alone? Can science contribute to that project? And finally, how would such a contribution relate to the perspective afforded by revelation and lived out in faith? Apart from his strictly scientific publications, which I won't mention here, Professor Barr has lectured on these questions we've been raising and written on them extensively, most notably in his books, Modern Physics and Ancient Faith, University of Notre Dame Press, 2003, A Student's Guide to the Natural Sciences, Intercollegiate Studies Institute, 2006, and most recently, Science and Religion, The Myth of Conflict, Catholic Truth Society, 2011. You can see from these titles that Professor Barr's interest in this field has a strong orientation towards youth, towards students at both the high school and the college level. And this made him an especially irresistible candidate for a symposium such as this. I should add that he was elected to the Academy of Catholic Theology in 2010 and made a Fellow of the American Physical Society in 2011. Symbolic juxtaposition of recognition for his work at the intersection of the two disciplines. Please join me in welcoming Professor Stephen Barr.
Good. First, let me just check, is this the right loudness? Good. Thank you, John. I'd like to thank Professor Cavadini and the other organizers of this conference for inviting me to participate. It's a great honor and a great privilege to address an audience as illustrious as this. I added a little preface to my talk this morning about the character of the talk that I'm going to give. We need to teach Catholics how to think properly about science and its relation to the truths of the faith. And we have to start doing this already at the high school or even elementary school level. If we wait till students are in college or even graduate school, it will be, in most cases, too late. You'll have lost them by then. So what I'm going to do today is to present to you some of the arguments and facts that I would present to high school students, more or less as I would present it to them, to an audience at that level. Now, there's much, much more to be said on this subject of science and religion than can be said in 45 or 50 minutes that my talk will take. When I was preparing this talk, I felt regret that I couldn't speak longer. You will probably have the opposite regret. Okay. I just want a show of hands. I'm just out of curiosity, to satisfy my own curiosity. Raise your hand if you know who that clerical gentleman is standing with Albert Einstein. Okay, good, because we're going to find out later who that is. And every Catholic student should know who that is. Does religion conflict with science? Certainly some religions do, including many pagan religions and those Christian sects that are based on narrowly literalistic interpretations of Scripture. The claim is often made, however, that science is incompatible with all religion, including the Catholic faith. That claim is false, of course, and I will show in this talk how far it is from the truth. But if it is false, why do so many intelligent people believe it? The answer is that people are mistaking one conflict for another. There is a real, long-standing, and often bitter conflict going on, but it is not between religion and science. It is between religion and a philosophy often called scientific materialism. The central tenet of this philosophy is very simple, and that accounts for much of its appeal. It is that the ultimate reality is matter, so that everything that exists and everything that happens can be explained by the laws of physics and blind chance. Everything, including you. For many of its adherents, however, scientific materialism is more than just a philosophy. It is a passionately held ideology that sees science as having a saving mission, which is to free men's minds from irrationality and superstition, among which they count religion. For them, the idea that there is a conflict between science and religion is part of what gives meaning and purpose to their lives, hence their zeal in propagating it. Scientific materialists have a well-developed critique of religion which has at least three strands: philosophical, historical, and scientific. The philosophical claim is that there is an inherent contradiction between the scientific and religious outlooks. Science is based on reason and evidence, whereas religion is said to be irrational because it is based on dogma, faith, and mystery, which involve belief in things that cannot be seen and for which supposedly there is no evidence. Science is based on natural explanations and natural laws, whereas religion is based on miracles and the supernatural. They see religion as a matter of myth and magic, and therefore pure superstition, which is the very antithesis of a rational scientific outlook. The historical claim is that religious believers and institutions have been hostile to science and have tried to suppress it. This is powerfully symbolized in the eyes of many by the Church's treatment of Galileo. And this impression is constantly reinforced in the public mind by the absurd battles waged against evolution by fundamentalist Protestants. The scientific claim is that the actual discoveries of modern science over the last 400 years have debunked or undermined fundamental Christian beliefs about the universe and mankind's place in it. As the story is often told, science has dealt one blow after another to the religious conception of the world. Copernicus showed that man is not the center of the universe. Newton showed that the world is governed by blind and impersonal forces. Modern astronomy showed how small and insignificant we are compared to the cosmos as a whole. Darwin, they say, showed that humans differ only in degree from lower animals, and discoveries in fields such as neuroscience and artificial intelligence are expected to show, if they haven't already, that the supposed soul is just the working of the brain, a complex biological computer. I will deal with each of these strands in turn. First, the philosophical. The philosophical critique is largely based on crude misunderstandings of traditional ideas about God and creation. Let's start with supernaturalism. Christianity and Judaism were never based on supernaturalism if we mean by that the rejection of the idea of a natural order. Indeed, scholars tell us that the book of Genesis was, in part, an attack on pagan supernaturalism and superstition. When Genesis said that the sun and moon were merely lamps placed by God in the heavens to light the day and night, it was attacking the paganism that worshipped the sun and moon. When it said that man was made in the image of God and was to exercise dominion over the animals, Genesis was, among other things, attacking the paganism in which men worshipped and bowed down to animals or to gods made in the image of animals. In paganism, the world was imbued with occult forces and populated by numerous deities. But Jews and Christians taught that there was only one God who was to be sought not within nature, not within its phenomena and forces, but outside of nature, a God who was indeed the author of nature. In this way, biblical religion desacralized and depersonalized the physical universe and made it indeed into a natural world, and thus helped to clear the ground for the later emergence of science. The biblical religions then taught that there is a natural order which comes from God, and what characterizes this natural order and reflects the rationality of its creator is precisely that it is orderly, harmonious, and lawful. Consider this passage from the letter of Clement to the Corinthians, written around 97 A.D. The heavens, as they revolve beneath his government, do so in quiet submission to him. The day and the night run the course he has laid down for them. Sun, moon, and starry choirs roll on in harmony at his command, none swerving from its appointed orbit. Laws of the same kind sustain the fathomless deeps of the abyss and the untold regions of the netherworld. The impassable ocean and all the worlds that lie beyond it are themselves ruled by the like ordinances of the Lord. Upon all of these, the great architect and Lord of the universe has enjoined peace and harmony. Or consider this passage from the Christian apologist Minucius Felix, writing around 200 AD. If upon entering some home you saw that everything there was well tended, neat, and decorative, you would believe that some master was in charge of it, and that he was himself much superior to those good things. So too in the home of this world, when you see providence, order, and law in the heavens and on earth, believe that there is a Lord and author of the universe more beautiful than the stars themselves and the various parts of the whole world. So it was not the supernatural or miraculous departures from the order of nature, but the order of nature itself and its lawfulness that point to its creator. The ancient argument was that if there is a law, there must be a lawgiver. God, let me just get off the text here. Let me go back to Einstein. The ancient argument was that if there is a law, there must be a lawgiver. God was the lawgiver not only to Israel, but to the cosmos itself. God says in Jeremiah 33:25, "When I have no covenant with day and night, and have given no laws to heaven and earth, then too will I reject the descendants of Jacob and of my servant David." Psalm 148 tells of the sun, the moon, the stars in the heavens, obeying a divinely given, quote, law that will not pass away. The idea of God as rational lawgiver very likely helped give birth to modern science, as even some atheists have at times conceded. For example, the eminent biologist E.O. Wilson suggested the following as the reason that Chinese civilization, for all its great advances and discoveries, did not produce a Newton or a Descartes. Quote, "Chinese scholars had abandoned the idea of a supreme being with personal and creative properties. No rational author of nature existed in their universe. Consequently, the objects they meticulously described did not follow universal principles. In the absence of a compelling need for the notion of general laws, thoughts in the mind of God, so to speak, little or no search was made for them." And the well-known cosmologist André Linde, who was an atheist, has suggested that the notion of a universe governed by a single law in all its parts is historically rooted in monotheism. The Catholic faith, of course, does teach us that there are supernatural realities, such as grace, that have effects in the world. But the word supernatural, which means above the natural, would make no sense unless there were a natural order in the first place. And the concept of miracles, which are extraordinary events that go beyond what is naturally possible, presupposes that there is a natural order that determines what is naturally possible and what is not. There is no logical contradiction between the idea of miracles and the idea of a lawful universe, for the same lawgiver who established the laws of nature can also suspend them. There's much confusion today, even among believers, about how nature relates to God. Instead of seeing God as the author of nature, they see God and nature as somehow opposed or in competition, so that if something has a natural explanation, they think God has nothing to do with it. And conversely, if God is the cause of something, it must be supernatural. Many, therefore, look for evidence of God only in what is outside the course of nature or inexplicable by science, that is, in the gaps in our scientific understanding, hence the expression, the God of the gaps. And atheists think that by closing those gaps, they will leave no place for God to hide. The traditional Christian view is quite different. If God, as creator of the natural world, established its laws and gave things their natural powers, then his existence is evident in nature itself and in its ordinary processes, whose power and working reflect God's own power and wisdom. This is the message of the following passage from the Book of Wisdom. For all people who were ignorant of God were foolish by nature, and they were unable from the good things that are seen to know the one who exists. Nor did they recognize the artisan while paying heed to his works. But they supposed... Was this? Yes. I had... is this right? Sorry. Let me start that again. For all people who were ignorant of God were foolish by nature, and they were unable from the good things that are seen to know the one who exists. Nor did they recognize the artisan while paying heed to his works. But they supposed that either fire or wind or swift air or the circle of the stars or turbulent water or the luminaries of heaven were the gods that rule the world. If through delight in the beauty of these things people assume them to be gods, let them know how much better than these is their Lord. For the author of beauty created them, and if people were amazed at their power and working, let them perceive from them how much more powerful is the one who formed them. For from the greatness and beauty of created things comes a corresponding perception of their Creator. Notice that the evidence of God to which this passage points consists of phenomena that are perfectly natural: fire, wind, swift air, the circle of the stars, turbulent water, and luminaries of heaven, that is, stars, planets, sun, and moon. Medieval theologians distinguish two ways in which God acts in the world. He can act directly in a supernatural manner, for example, turning water into wine, or he can accomplish his will through the operation of natural causes and processes. It has always been the Catholic view that God ordinarily acts in the latter way. In the words of Suarez, God does not interfere directly with the natural order where secondary causes suffice to produce the intended effect. This principle was important for the founding of science, for it implied that when confronted by some puzzling event or new phenomenon, we should look first for natural explanations. Superstitious people tend to see the supernatural in every unusual or strange event, but this was strongly criticized by the great medieval scientist-theologian Nicholas Oresme. In explaining marvels of nature, he said, quote, "There is no reason to take recourse to the heavens or to demons or to our glorious God, as if he would produce these effects directly, any more than he directly produces those effects whose natural causes we believe are well known to us," unquote. Another great medieval scientist theologian, Jean Buridan, said that when confronted by new phenomena, we should seek appropriate natural causes. That's why the Church does not declare a miracle to be worthy of belief until it has excluded the likelihood of natural explanations. This brings us to the all-important theological distinction between primary and secondary causality. I think the failure to grasp this distinction is one of the main reasons that people see a conflict between science and religion. This distinction is most effectively explained to ordinary people, I have found, and to students, by using a simple analogy and by employing the terms vertical and horizontal cause rather than primary and secondary. The analogy is to a novel, say Dostoevsky's Crime and Punishment. In that novel, the character Raskolnikov kills an old pawnbroker woman with an axe. I often ask audiences, did the pawnbroker die because Raskolnikov struck her with an axe? Or did she die because Dostoevsky wrote the novel that way? Audiences often laugh because they see how absurd the question is. Obviously, both are causes, but at different levels. Raskolnikov is the cause within the novel of the woman's death, the horizontal or secondary cause, whereas Dostoevsky is the vertical or primary cause of the whole novel and its entire plot, including, of course, the woman's death. There is no competition or conflict between these two levels of causality. By analogy, the natural causes within the universe, which are studied by scientists and others, are horizontal or secondary causes, while God, as the author of nature, is the vertical or primary cause. The analogy makes clear just how silly it is to treat evolution and creation as alternatives, as both fundamentalists and atheists do. Did this species of animal arise by natural processes, or because God wrote nature's script that way? Of course, both. This also makes clear why scientific materialists are wrong to think we believe without evidence. For materialists, evidence means either directly observing something with our five senses or inferring that something exists as a natural cause of what we observe, the way we observe a compass needle move and infer that there is a magnetic field. Obviously, God cannot be seen in those ways, for he is neither a part of nature, which could be sensed, nor a natural cause. And yet God is a cause, the ultimate cause. He is not a cause within nature. He is the cause of nature. Thus, nature gives evidence of God in the same way a novel gives evidence of its author, even if the author is not to be found within the pages of the book. And this brings us to the very fundamental point that Cardinal Willett made yesterday. God explains why there is a universe at all. There are many things we can understand about the universe by internal explanations, just as there are many things you might explain about a literary work without adverting to its author, just by internal explanations. Perhaps this word is there because it rhymes with that word, or perhaps the words are laid out this way because the laws of English grammar. And the laws of English grammar for a novel are analogous to the laws of physics for the universe. But there are certainly things about the novel you can't explain without just internally. Why is there a novel at all? Well, for that, the cause of the novel is the author and the cause of the universe. The reason that anything exists at all, of course, is God. Now let me turn to the materialist's historical critique of religion. The idea that Christianity and the Catholic Church in particular opposed science and tried to hold it back is called by historians the conflict thesis. It has been completely discredited by historians of science. It is a myth, pure and simple, whose roots lie in the Enlightenment and the contempt many of its thinkers had for revealed religion. Its growth was aided in Catholic countries by anti-clericalism and in Protestant countries by anti-Catholic prejudice. The conflict thesis was popularized by two enormously influential books written in the late 19th century. The History of the Conflict Between Science and Religion by John William Draper, and A History of the Warfare of Science with Theology in Christendom by Andrew Dixon White, the first president of Cornell University. These books are dismissed by scholars today as full of errors of fact and interpretation and historically worthless. One historian called Draper's book a thinly disguised anti-Catholic rant. The scientific revolution, which took place in the 17th century and gave rise to modern science, did not occur in opposition to revealed religion. In fact, most of the great figures of the scientific revolution were devout Christians. Copernicus, whose work sparked the revolution, was an official of the Catholic Church. Johannes Kepler, famous for his 3 laws of planetary motion, announced the discovery of one of them with the words, "I thank thee, Lord God, our Creator, that thou hast allowed me to see the beauty in thy work of creation." Galileo remained a devout Catholic throughout his life. Descartes, whose work in mathematics was foundational for modern science, believed in God and the immateriality of the soul. Blaise Pascal was not only a mathematician and physicist of genius, but a Catholic mystic. Robert Boyle, the first modern chemist, left a large sum of money to endow a lecture series whose purpose was to combat the ideas of, quote, notorious infidels, that is, atheists. And Isaac Newton, the greatest of them all, spent as much time on theological and scriptural studies as he did on science. All of these men saw their work as showing the beauty of God's creation rather than as supporting atheism. And this was true long after the 17th century. For example, the two greatest physicists of the 19th century, Michael Faraday and James Clerk Maxwell, were deeply devout Christians, even by the standards of their time. Indeed, I think it would be fair to say that most scientists, until probably sometime in the middle or late 19th century, were religious. Moreover, the scientific revolution did not come out of thin air. Its foundations were laid in the universities of medieval Europe, as has been strongly emphasized by the distinguished historian of science Edward Grant. It was in those universities that for the first time in human history, science was studied and taught on a continuous basis from generation to generation by a stable community of scholars. That is, where science was first institutionalized, as Edward Grant put it. These universities produced hundreds of thousands of graduates who were introduced to scientific questions and from whose ranks scientific talent could emerge. The scientific community and scientific public those universities produced were the soil in which the seeds of the scientific revolution germinated. A little-known fact that dramatically illustrates the positive role the Catholic Church has played in the development of science is the large number of Catholic priests who made major discoveries. I have time only to mention a few of the most outstanding. And here I'm going to show you some pictures. In the Middle Ages, there were St. Albert the Great, Robert Grosseteste, Thomas Bradwardine, and Nicholas of Oresme, all bishops, incidentally. St. Albert did original work of observation and classification in botany and zoology. The Dictionary of Scientific Biography calls his work on vegetables and plants, quote, a masterpiece for its independence of treatment, its accuracy and range of detailed description, its freedom from myth, and its innovation in systematic classification, unquote. Grosseteste studied the refraction of light and came up with a geometrical theory of how lenses magnify images that was essentially correct. Thomas Bradwardine showed that Aristotle's ideas on the relation of force and motion were not self-consistent and developed his own mathematical theory of them. His was one of the first attempts in history to give a mathematical formula to describe a physical process. Oresme was a genius who made many contributions to mathematics and physics that were far ahead of his time. For example, he was the first to graph physical quantities, thus anticipating by 3 centuries some of Descartes' ideas. And he used that method to prove an important theorem about accelerated motion. He correctly proposed that the speed of a falling body is proportional to the time it has fallen, which anticipated Galileo's famous law of falling bodies. In the 17th century, the century of the scientific revolution, we find Niels Stenson, Marin Mersenne, Christoph Scheiner, Giambattista Riccioli, Francesco Grimaldi, Benedetto Castelli, and Bonaventura Cavalieri. Niels Stenson, also known as Steno, not only made major discoveries in the field of anatomy, many parts of the human body are named after him, Stenson's duct, Stenson's vein, Stenson's foramina, and so on. But he is considered the founder of geology for developing the theory of sedimentary rocks and the origin of fossils, which unlocked the history of the Earth. Google actually celebrated his birthday one day. This is showing sedimentary rocks and fossils embedded in them. Marin Mersenne is considered the founder of acoustics for fundamental discoveries in the theory of sound and vibrations. His convent became a meeting place of famous scientists, and his voluminous correspondence with other scientists was an important means by which scientists learned of each other's work. The Dictionary of Scientific Biography calls him one of the architects of the European scientific community. Christoph Scheiner was one of the discoverers of sunspots and made the most detailed studies of them. Riccioli was an astronomer who discovered the first binary star, and also, together with Francesco Grimaldi, who I'll mention in a moment, made the first maps of the moon's surface. In fact, because of the work of these Jesuit astronomers in studying the moon's surface, it became a tradition to name craters of the moon after Jesuit astronomers. Dozens of the largest craters on the moon are named after Jesuit astronomers. Grimaldi discovered the extremely important physics phenomenon of the diffraction of light. If you've studied physics in your freshman physics course in college, there will be an entire chapter devoted to diffraction. And diffraction is very important in every branch of physics. Diffraction is a phenomenon that shows that light is a wave. And in fact, diffraction happens for all kinds of things and shows that other things besides light, electrons, other particles, are also waves. By the way, if you have a DVD or a CD and you see those colored bands, those are diffraction bands. So every time you see those colored bands, you should think of Father Grimaldi, who discovered them in the 17th century. Benedetto Castelli is the founder of hydraulics. Cavalieri made important advances in the development of integral calculus. In the 18th century, there were Lazzaro Spallanzani, one of the leading biologists of that era. His contributions to biology are too numerous to mention. And René Just Oey, the founder of crystallography. Here's a picture of him holding in his hand a crystal and measuring it. In the 19th century, one has Giuseppe Piazzi, who discovered the first asteroid Ceres, and there's a picture of Ceres taken by the Hubble Space Telescope. Angelo Secchi was one of the founders of modern astrophysics. All astrophysicists know and honor the memory of Angelo Secchi. He pioneered the use of spectroscopy in astrophysics, and he made the first classification of stars. It was based on their spectra, and which is the basis of our present classification of stars. A beautiful image of the harmony between science and religion is that Secchi actually used an observatory built on the roof of Sant'Ignazio, one of the most beautiful churches in Rome, to make some of his fundamental discoveries in astronomy. Bernard Bolzano, a Czech priest, helped put modern mathematics on a more rigorous footing. Here's a quote from the Stanford Encyclopedia of Philosophy. He was an outstanding mathematician and possibly the greatest logician in the period between Leibniz and Frege. Anyone who has studied advanced math has heard of the Bolzano-Weierstrass theorem and Bolzano's function and so on. He was a major figure in 19th century mathematics. And of course, there's Gregor Mendel, who founded the science of genetics. In the 20th century, we have Julius Newland, a chemistry professor here at Notre Dame, who did work that led to the development of neoprene, the first synthetic rubber. And last but not least is the gentleman I showed you at the beginning of my talk. There's another picture of him chatting with Einstein, Georges Lemaitre, the founder of the Big Bang Theory. How many Catholic students know that the Big Bang Theory, which is the pillar of modern cosmology, was proposed by a Catholic priest? In my view, on the wall of every of at least one science classroom in every Catholic school in this country, there should be a poster or posters about these important priest-scientists who founded entire branches of science: geology, acoustics, Big Bang cosmology, crystallography, genetics. The Church has nothing to be ashamed of when it comes to science and her role in the history of science. It is, in fact, a glorious record of achievement. Professor Lawrence Principe of Johns Hopkins University has written that, quote, "The Catholic Church has probably been the largest single and longest-term patron of science in history," unquote. The rest of my lecture will deal with the third strand of the materialists' critique of religion, the notion that many of the greatest discoveries of modern science have undermined or debunked the traditional Jewish and Christian view of the universe, of man and of man's place in the universe. As things stood 100 years ago, this view had some plausibility, but much has changed since then. There have been several major discoveries or developments, especially in physics, that seem more consonant with the Christian and Jewish conception of the universe and of man than with the materialists. I would like to discuss 5 of them. In each case, I will mention earlier discoveries that seem to favor the materialists' view, and then the more recent discovery or development that points the other way. The first has to do with the structure of the cosmos. We have all heard how Copernicus overturned the religious picture of the cosmos by showing that man is not at the center of it, and how later discoveries demoted us even further by showing that the Earth is just a tiny speck lost in the vastness of space. Actually, however, the idea of the Earth as at the center of the universe did not come from the Bible, but from ancient Greek science, specifically from Aristotle and Ptolemy. Nor was the center a place of honor in Aristotle's cosmos, but the lowliest, and the farther things from it, the farther things were from the center, the more noble and exalted they were. There was one idea about cosmology that did enter Western thought from biblical revelation. It was not about space and whether it had a center. It was about time and whether it had a beginning. The pagan thinkers of antiquity, including Aristotle, conceived of the universe as having had no beginning. Modern atheists have also tended to prefer this idea. And until about 100 years ago, almost every indication from science seemed to support the idea of an eternal universe, or at least a universe without a temporal beginning. Physicists discovered that the amount of energy never changes. It, quote, cannot be created or destroyed. Chemists found that the number of atoms never changes in chemical processes, in chemical reactions. In Newtonian physics, time extended infinitely into past and future, just as space extended infinitely in all directions. Almost everything suggested that matter, energy, space, and time had always existed and always would. The idea of a beginning came to be seen as outdated religious mythology. The Nobel Prize-winning chemist Svante Arrhenius said in 1911, quote, "The opinion that something can come from nothing is at variance with the present-day state of science, according to which matter is immutable," unquote. The Nobel Prize-winning physicist Walter Nernst declared, quote, "To deny the infinite duration of time would be to betray the very foundations of science," unquote. And I should say that even as late as the 1950s, a poll showed that a majority of American scientists, astronomers and physicists, believed that the universe had no beginning. But in 1916, Einstein proposed his theory of gravity, called general relativity, and everything changed. In the 1920s, the Belgian theoretical physicist Georges Lemaitre, who was also a Catholic priest, realized that the equations of Einstein's theory could describe a universe whose space was expanding. Combining this with the observation by astronomers that distant galaxies were receding from us, Lemaitre proposed what is now called the Big Bang theory. It took a long while to gain acceptance, partly because of philosophical prejudice against the idea of a beginning. But in time, the evidence grew overwhelming that the hypothesized Big Bang did occur about 14 billion years ago. In the standard Big Bang theory, everything began at that point: matter, space, and time itself. It is possible that something preceded the Big Bang, and that it wasn't the absolute beginning of the universe, but perhaps only the beginning of some phase of its history. There are, however, strong theoretical reasons to think that the universe did have an absolute beginning a finite time ago, if not at the Big Bang, then at some earlier point. So science now strongly supports an idea that came from biblical revelation and was dismissed both by the pagans of antiquity and modern materialists, and for a long time seemed contrary to science. The second development I'll speak about has to do with evidence of design in nature. Religious believers have always seen such evidence: the starry heavens, the forms of living things, and the other wonders of nature were seen as having been fashioned by the hand of God, at least metaphorically speaking. Modern science seemed, however, to undercut this idea by showing that they were the result of mechanisms that depended upon a combination of impersonal laws and blind chance. Whereas Genesis spoke of God placing the sun and moon in the firmament, astrophysicists showed that they condensed from swirling clouds of gas and dust under the attraction of gravitational forces. Darwin showed how the intricate structures of living things could arise from natural selection operating upon random mutations. When Napoleon asked the physicist Laplace why God was never mentioned in his great treatise on celestial mechanics, Laplace famously replied that he, quote, had no need of that hypothesis. The laws of physics had displaced God. This was a new way of looking at the laws of nature. From ancient times, it had been argued, as we've seen, that the lawfulness of nature pointed to a lawgiver. But now it was argued that the laws of nature, in and of themselves, constituted a sufficient explanation for the order of nature. And this does seem to make a certain amount of sense if one thinks about the shapes and patterns that we see in tangible objects or collections of objects, such as crystals or seashells or sunflowers or the motions of heavenly bodies. Consider, for example, the solar system. It exhibits many striking patterns, 3 of which were discovered by Johannes Kepler. He found that each planet followed an elliptical orbit, with its speed varying in such a way that the line connecting the planet to the sun sweeps out equal areas in equal times. He also discovered a simple algebraic relation between the period of a planet's orbit and its distance from the sun. All these and many other patterns in the solar system can be explained by the laws of Newtonian physics. Does that mean, however, that the laws of Newtonian physics explained the existence of cosmic order? No, quite the reverse. For how did Newtonian physics explain the order in the solar system? It did so appealing to a deeper order throughout the whole universe. It showed that Kepler's 3 laws of planetary motion follow from Newton's more fundamental laws of mechanics and gravity. But Newton's laws describe an order far grander and more impressive than the laws of Kepler. There was more cosmic order to explain after Newton than before. And where does the greater order discovered by Newton come from? Newton's law law of gravity comes from a yet more fundamental law, from yet more fundamental laws, namely the equations of Einstein's theory of gravity. And lo and behold, the mathematical order described by Einstein's laws is even more splendid, beautiful, and profound than that found by Newton. And the process continues. It is believed that Einstein's laws, in turn, can be derived from yet more beautiful and profound laws, very likely those of so-called superstring theory. This is what the progress of physics, especially in the 20th century, has shown to us with ever greater clarity. The deeper we probe into the hidden workings of the physical world, the richer, more intricate, and more magnificent the mathematical structure we find. And we find this beautiful structure in the mathematical laws themselves. All of this has changed the context in which we think about design in nature. When the questions that scientists asked were simply about shapes or patterns seen in tangible things, however beautiful, it may have seemed naive to speak of them as fashioned by the hand of God. They could be accounted for by the operation of the laws of physics. But now that the laws of physics themselves have been found to form a magnificent mathematical edifice of great subtlety, harmony, and beauty, the question of a cosmic designer has returned with greater force than ever. In 1931, the great mathematician and physicist Hermann Weyl gave a lecture in which he said the following, quote, "Many people think that modern science is far removed from God. I find, on the contrary, that it is much more difficult today for the knowing person to approach God from history, from the spiritual side of the world, and from morals, for there we encounter the suffering and evil in the world, which it is difficult to bring into harmony with an all-merciful and almighty God. In this domain, we have evidently not yet succeeded in raising the veil with which our human nature covers the essence of things. But in our knowledge of physical nature, we have penetrated so far that we can obtain a vision of the flawless harmony which is in conformity with sublime reason." So when Minucius Felix talked about the providence, order, and law in the heavens and on earth as evidence, as which he was giving to his pagan contemporaries, as evidence of God, we have far more evidence today, because we see far more law. Many features of the laws of physics seem arranged just so as to make life possible in our universe. These are sometimes called anthropic coincidences. I could give you many examples, but for reasons of time, I'll mention only a few. One example is that if the world did not obey the principles of quantum mechanics, atoms and molecules would not be stable building blocks with well-defined properties out of which living things could be built. If the down quark were lighter than the up quark instead of heavier, then ordinary hydrogen, on which all life depends, would be radioactively unstable. If the so-called strong force, which holds nuclei together, were even a small fraction weaker than it is, a crucial nucleus called deuterium could not exist, and the nuclear reactions that power the sun and similar stars would not take place, depriving Earth of the energy needed for life. In fact, it would be more disastrous because if deuterium cannot exist, then neither would almost all of the heavier elements in the periodic table. The world would be entirely composed of hydrogen. If the number of extended dimensions of space, physicists think that there might be more than 3 space dimensions, but there are only 3 large dimensions, extended dimensions. If the number of extended large dimensions of space were greater than 3, gravity would act differently and not allow planets to orbit stars. Planets would either plunge into the stars or fly off into space. If the number of large dimensions were less than 3, other disasters would occur. 3 space dimensions is a very special number if you want to have a universe with life in it. The simplest way to explain these and many other anthropic coincidences is to say that whoever designed the laws of nature did so with the purpose that life should arise in it, in the universe. There is, I should note, an alternative explanation to some of these anthropic coincidences called the multiverse idea, which I haven't time to explain in the talk. It should be taken seriously, by the way. If the universe is a multiverse, as it well may be, it would explain some, though not all, of the anthropic coincidences, but it wouldn't dispose of the evidence for purpose in nature, since a multiverse must itself have very special laws. Thus, in one way or another, the laws of physics have to be special for life to arise. The fourth development I'll discuss has to do with the issue of determinism and free will. For hundreds of years, all indications were that the mathematical laws of physics are deterministic. That is, given the state of the universe at one time, the equations would determine its whole future development uniquely, as was famously asserted by Laplace 200 years ago. This was a powerful objection to the idea of free will and greatly disturbed religious thinkers. The idea of physical determinism is, given the state of the universe, for example, 1 billion or 5 billion years ago, everything that happened after that, including my lifting up this glass of water, the words that are coming out of my mouth, everything would be uniquely determined by the equations of physics. That's why it's a very big challenge to the idea of free will. And if anything seemed solidly supported by science 100 years ago, it was physical determinism. But then, to the astonishment of physicists, determinism was overthrown by quantum mechanics in the 1920s. For it turned out that a fundamental feature of quantum mechanics is that its equations do not, generally speaking, predict what will happen, but only the relative probabilities of various future outcomes. This has seriously weakened the fundamental physics objection to the possibility of free will. To quote Hermann Weyl's 1931 lecture again, quote, "We may say that there exists a world causally closed and determined by precise laws, But the new insight which modern quantum physics affords opens several ways of reconciling personal freedom with the laws of nature. It would be premature, however, to propose a definite and complete solution of the problem. We must await the further development of science, perhaps for centuries, perhaps for thousands of years, before we can design a true and detailed picture of the interwoven texture of matter, life, and soul. But the old classical determinism of Hobbes and Laplace need not oppress us longer, unquote. The fifth and last development that I'll discuss has to do with the question of whether mind is reducible to matter, as materialists claim. As biological processes have increasingly been understood in terms of chemistry and physics, and as neuroscience has shown how intimate the connection is between mental phenomena and events in the brain, many people have become convinced that mind is simply an emergent property of matter. This conviction has been strengthened by the increasing ability of computers to perform tasks that, in humans, require intelligence, such as playing chess or translating languages. This has led people to say that we ourselves are just computers, are just, as some have said, machines made of meat, or wet computers. However, two of the epoch-making discoveries of the 20th century have cast considerable doubt on the idea that the human mind is but the operation of a physical mechanism. These discoveries are quantum mechanics and Gödel's theorem. I can only discuss them very briefly, since I'm almost at the end of my talk. Quantum mechanics, as traditionally understood, distinguishes between physical systems on the one hand and conscious observers of those systems on the other. The reason, in very rough terms, is the following. Quantum mechanics, as I mentioned before, deals with probabilities. Probabilities have to do with what someone knows or doesn't know. The more you know, the less you have to rely on probabilities. The one who knows or doesn't know the state of a physical system is traditionally called the observer in quantum mechanics. And to know requires a mind and consciousness. So that's how mind, even though quantum mechanics is a description of the physical world, this is how mind and consciousness get into the picture when you discuss quantum mechanics. So probabilities refer to knowledge, and knowledge requires a mind or a consciousness. Thus, it has been argued by some eminent physicists that quantum mechanics implies that mind and consciousness are as fundamental to the constitution of the world as matter is. Heisenberg himself said, for example, that the mathematics of quantum mechanics, quote, represents no longer the behavior of physical systems, but rather our knowledge of their behavior, unquote. And Sir Rudolf Peierls, a leading 20th century physicist, said, quote, the quantum mechanical description is in terms of knowledge, and knowledge requires somebody who knows. And he emphasized the word somebody who knows. The Nobel Prize-winning physicist Eugene Wigner commented that, quote, the very study of the physical world led to the conclusion that the content of the consciousness is an ultimate reality, unquote. Moreover, an argument that goes back to the great mathematician John von Neumann says that the mind of the observer in quantum mechanics, the mind of the observer is not completely describable by physics within the framework of quantum mechanics. Here is Peierls again, quote, the premise that you can describe in terms of physics the whole function of a human being, including his knowledge and consciousness, is untenable. That is why Wigner stated that materialism is not, quote, logically consistent with present quantum mechanics. Gödel's theorem was a profound discovery made in mathematical logic in 1931 by Kurt Gödel, one of the greatest mathematicians and logicians of the 20th century. What he showed was that there is more to doing mathematics and to discovering mathematical truth than merely mechanically following rules, the way a computer does, for instance. From this, some have argued that the human mind, when thinking mathematically, is not just operating like a machine. Gödel himself rejected the materialist view of mind, calling it, accurately, a prejudice of our time. The philosopher John R. Lucas of Oxford University wrote in 1961, quote, "Gödel's theorem seems to me to prove that mechanism is false, that is, that human minds cannot be explained as machines. So also has it seemed to many other people. Almost every mathematical logician I have put the matter to has confessed to similar thoughts," unquote. Lucas developed a careful argument against the mechanistic view of mind based on Gödel's theorem. Since the mid-1980s, this Gödelian argument has been championed and further refined by the eminent mathematician Sir Roger Penrose, also of Oxford University. A point that Lucas and Penrose emphasize is that the human mind is capable of doing something that a mere computing machine cannot, namely understanding concepts and grasping meaning. I should make clear that most scientists would be skeptical of the anti-materialist arguments based on quantum mechanics or Gödel's theorem. Nevertheless, those arguments have been advanced and defended by some of the most brilliant scientific and mathematical minds of the 20th century. One thing, therefore, is clear. Materialism is definitely not a conclusion to which modern science necessarily leads. We see then that the discoveries of the 20th century have shown us a world that looks more like the world of Christian faith than did the science of 100 years ago. We find the universe probably did have a beginning after all. We find that the laws of nature have a richness and profundity of mathematical structure that bespeaks design. We find in those laws many features that suggest that the universe has a purpose, which is to give rise to life. We find that the determinism that seemed to refute the possibility of free will has been overthrown. And we find that some of the deepest discoveries of physics and mathematics suggest, and perhaps prove, that there is more to the human mind than physics or mathematics can describe. I've covered a lot of ground. I hope I've shown that the Catholic Church has been a friend of modern science and has, in turn, nothing to fear from modern science. The real antagonist of religion is not science itself, but scientific materialism, a reductive philosophy that comes from a blinkered view of reality and, indeed, a blinkered view of science itself. I thank you for your attention.
Thank you very much, Professor Barr, for a very stimulating presentation. And now I hope we will have a robust question and answer session.
Can I, before that, just say one thing? In my talk, I focused on physics-related things. I didn't talk about human dignity. I didn't talk about love. I didn't talk about many, many things, the origin of man. Only touched on one sentence on evolution. There are many, many subjects that come into play when you're talking about science and religion. As a physicist, I focused on the physics side of things. But I want to call your attention to a wonderful book that is comprehensive in its treatment of science-religion issues. It's a textbook written for Catholic students. It's written to be a textbook in Catholic high schools on the subject of science and religion, written by Chris Baglow, who's going to be talking later at this conference. And I want to say I think this is a magnificent work, and I think every one of you should take home a copy and read it, because this is how the subject should be presented to Catholic students, to Catholic high school, and even college students. Okay.
Thank you. Well, I'm sure Professor Barr would be delighted to hear some questions.
Thank you very much, Professor. The question you asked last night led me to conclude, perhaps erroneously, that you're sensitive to caricatures, and that
I indulge in them myself a lot.
Yeah, I know, most preachers do too. But I was recalling, as you were talking about the historical argument or the myth, if you will, an observation of Charles Taylor that in the 17th century, even well-meaning people like Boyle, who established his legacy, allowed the debate to be framed in a way that was ultimately going to lead to the destruction of a harmonious relationship between faith and science. Now, I think today you can see clearly that a fundamentalistic reading or literal reading of the first 5 books of Scripture can lead you that way. Are there, and I think most people in this room wouldn't subscribe to that, but do you sense in sort of mainline Catholicism and its dialogue with science some caricatures of which we should be sensitive and at least questioning?
Okay. There's 2 sort of questions there. One having to do with the way people like Boyle, religious people who were scientists, framed issues in a way that lent themselves actually to distorting religion. In fact, deism, for example, there are ways of harmonizing faith and science which lead one into a deistic, not to Catholicism or a Catholic way of looking at things, but a deistic way. In fact, I gave a talk, it might have been in this very room, I gave a talk here on the Notre Dame campus several years ago, and it was heavily physics-oriented. And one person stood up and asked, it sounded like I was a deist, because I'm talking about this sort of God, the mathematician, who ordains the laws of physics and so on and so forth. But somehow I'm not talking about how God is sort of intimately involved in his creation. I said, wait, I'm a Catholic. God is intimately involved in his creation in many ways, aside from sustaining it in existence at every moment in time. There's divine revelation, and there's the incarnation, and there are miracles, and there are the sacraments, and there's the indwelling of the Holy Spirit, and there's all of these things we believe as Catholics. But of course, I'm talking about physics, okay? And so physics, I'm not even talking about sentient beings except when I talked about the last part of my talk. But when you're talking about physics, you're not talking about sentient beings, let alone rational beings such as ourselves made in the image of God. And so you can actually sound like, it's all a nuts and bolts universe and a sort of a deistic picture. So that's why I sort of apologize that my talk is sort of heavily physics-oriented. I think you need, there are many science-religion issues that you have to explain to kids about what it means to be a spiritual creature, that we have reason and free will, and so on. You have to explain what it is, what a person as opposed to a thing is. And as I said, why I suggest this book is so good, because it doesn't just do the physics questions. Are there caricatures? Yes. I don't want to, you're going to get me sort of in a whiny mode here. I'll say this. We live in a culture that's very heavily, the number of actual scientists is quite small. But there's a far larger number of people who come at things from a scientific angle, who are scientifically educated, who are who see the world through scientific eyes. We live in perhaps most educated people in our society, to a large extent, see the world through a scientific eyes. And that means that those people who are engaged, we have to evangelize that world. We have to evangelize the world of scientists, and we have to evangelize the world of scientifically minded people. And the people who should be doing that evangelization should be people who love science, not people who fear science. And, a lot, when I hear some Catholic philosophers and theologians, and I don't want to mention any names, but I've read many articles and when they talk about science, the fear is palpable. The anxiety, the nervousness about science is palpable. You know, like dogs can smell fear. You can smell their fear of science. And it shows itself in a desire to cut science down to size. They want to cut it down to size, put it in its place. And so they say things like, science is merely telling you, say physics is merely telling you about superficial quantitative aspects of things. It doesn't tell you about essences. It doesn't tell you about... I won't go into the litany of things, but there's a certain line that you hear that, it all started by, it all went to hell with Francis Bacon and Descartes. Science was going along great until, Descartes and Francis Bacon screwed the whole thing up, threw out the final and formal causes, kept the material and efficient causes. As a result, science has been distorted and deformed ever since. There's a lot wrong with that, a tremendous amount wrong with that history. It's a caricature. I won't go into the subject at length, but to say that science has gotten rid of formal cause is laughable, in my opinion. In fact, in modern physics, what does modern physics do? It understands the physical world in mathematical terms. Mathematics is the study of form. That's what math is. It's the study of form. And the fact that physics describes the world in mathematical language is telling you that it's form all the way down. As you go deeper into physics, you find form all the way down. Its formal causes are the most important in modern science. So anyway, I don't want to get on that whole digression, but there are these stories that many people tell themselves about science with the idea, as I said, of putting it in its place, of putting it in a little box where it won't cause us any trouble. And those people are not the people who should be evangelizing, doing science religion stuff with students. They shouldn't be the ones talking about science, okay? Just because, as I said, the fear or the anxiety that is so easy to detect in their way of speaking. Unfortunately, it should be people who themselves are coming from a scientific orientation. Those are the best people to do this job. The people who know, love, and understand science from within should be shouldering this burden. There are not enough of such people around, but those are the people who should be leading the effort. Yeah.
Yes, Father Wynandy.
I have a twofold question. My first question is, you talked about how the Big Bang Theory helps to explain a beginning and so is compatible with what we read in Genesis or within the Catholic tradition. I presume the compatibility lies in if the universe has a beginning, therefore there must be someone who began it, a creator God. But you did not make that connection at all. Is that because as a scientist, while you can say the world had a beginning, you can't really say why the beginning began?
No, that's not astute of you to notice. In my book, Modern Physics and Ancient Faith, I have a whole section on the Big Bang Theory and how it vindicates the Jewish and Christian notion that the universe had a beginning in time. But I do not use it as an argument for a creator, because I think that St. Thomas had this right. For a number of reasons. First of all, St. Thomas believed that you could prove from reason, from the natural light of reason, from philosophical arguments, that the world is created. But he did not believe that one could prove by philosophical arguments that the universe had a temporal beginning. He distinguished those two questions. In fact, he said that God could have created a world which had no temporal beginning, which was, as physicists would say, past eternal. And there's no way we know that the universe had a beginning except by divine revelation. So now a lot of people, I think it's the analogy I use in my book and when I talk to audiences about the Big Bang. People think, well, if something was created, it had to have a beginning. They can't separate those two notions in their mind. And that's true of human artifacts. If a human being makes a painting or builds a building, then the building had a beginning in time. So they say, how can something be created and not have a beginning? Well, I use the analogy of something, a screen illuminated by a light. The light is the cause of the screen's illumination. That doesn't tell you whether the screen has been illuminated for a finite time or for infinite time. The screen could have been illuminated for infinite time by that lamp, in which case it always was illuminated and it always had a cause. That illumination always had a cause. In the same way, God, the universe has being, God is the source of that being, but that being could have been around for infinite time. And Aquinas understood this. I personally think it's a mistake so I only argue that I'm only making the argument that the biblical religion said there was a temporal beginning. The pagans and modern atheists have tended to dislike that idea intensely, and lo and behold, science now supports it. So that's as far as I go. I think there might be a big risk in trying to prove from the fact that the universe had a beginning in time that therefore it had a creator. Because I think that is reinforcing bad ways of thinking about God. Because it reinforces the idea of God as a horizontal cause of things, a deistic notion of God. Well, here's God, and he wound up the watch, or God, as Stephen Hawking said, lit the match and set off, put it to the fuse and set off the explosion, which is the Big Bang. Many atheists and religious people have that idea as God. In fact, one well-known evangelical Christian chided me in the pages of First Things because he said, you need God as the force, he used that word, that caused the Big Bang. In that way of thinking, of putting God there as the force that starts the universe, tends to bring him down to the level of creatures as another horizontal cause in a temporal sequence of causes. And I think that's a mistake. I think we have to get across to the students that God is not in a temporal sequence with the universe. He is like the author of a book. The author of a book doesn't just write the beginning of the book. There's a difference between the beginning of something in the sense of its starting point and the origin of the thing. The beginning of the book are its first words. The origin of the book is the author. And the author is creating every word of the book equally. God is creating me right now. He is creating this. He is creating this. He is the maker of all things, visible and invisible, every moment of space, every moment of space and time.
Could I just, you answered the second point, because my fear was that if we base our belief in the beginning of the world on the Big Bang, if the Big Bang ever goes bang and nobody believes it anymore, then it undermines our faith. So with Aquinas, with the eternity of creation, I think it's important to keep that in mind because the Big Bang could be for all eternity as well. And that, if the Big Bang's for all eternity, that still does not undermine the Christian notion of creation.
That is correct. And that's why I'm very careful in my book and in my talk. I don't say that the Big Bang proves the beginning. I only say that at the moment, there are powerful theoretical arguments that suggest that the universe probably had a temporal beginning, if not at the Big Bang, at some point. And that is true. And that's why you never want to claim more the evidence supports. I don't think it may never be possible to prove that the universe had a temporal beginning. On the other hand, I also think it will never be possible if the universe, even if the universe had no temporal beginning, I don't think it would ever be possible to prove that either. I think this will always remain an open question, but there's a very heavy weight of theoretical argumentation that suggests that it did. And I think we ought to make apologetic use of that.
Bishop Burns had a hand up, I think, or this is going to need to be our last question, I'm afraid, because we have to have our break. So probably also will need to be a relatively brief.
Sure, I'm sorry.
I'll try. That's fine. We appreciate your answers.
Just your comments last night and today made me reflect on my own experience. I majored in microbiology at that university up in Ann Arbor. I remember my biochemistry class, the first day was all life can be explained by physical and chemical reactions. Still remember the quote. Even though I'd had a very poor catechesis really through the 70s, it made a lot of collages. Jesus Christ Superstar, Godspell were my portrayal of Jesus. Somehow I persevered, mainly because I had come to understand Jesus as infinitely wise. Now I'm going, probably the whole end of the conference here to the whole pastoral, but it strikes me that my generation, perhaps others, have been fed on a very low Christology, and it's hard to trust Jesus if, well, you just gave me the word here, if he's one of the horizontal causes. Mm-hmm. He's just in the middle here. That seeing him as the Lord, the one through whom all things were made, a very high Christology, makes more sense and makes science, you see science in its place. So I just wanted to offer that as a reflection.
Yes, I think an image of God that would be accessible or congenial to scientific-minded people would be a God as an infinite mind. The God is the one who grasps all, who understands everything in one eternal act of insight. That image of God. Because I think sort of a Lonerganian, perhaps Father Spitzer will talk about this, I think a Lonerganian way of looking at God, though it's also St. Thomas's, if the world is completely intelligible, then that in some sense presupposes that there is some act of understanding that fully grasps it. If something is intelligible, it means that there's some act of understanding by which it would be understood. And if all of reality is intelligible, which physicists, scientists believe, that's what drives their quest. If all of reality is intelligible through and through, then that in a way could be argued to show that there is some act of understanding, some act of intelligence that would grasp it all, and God is that act of understanding.
Well, thank you very much. I'm going to avail myself just for a moment. Well, I appreciated your talk. We all did, about your distinctions between primary cause and secondary causes and all of that. I found it interesting, personally, the point that it seems reasonable, pretty evident, as you quoted from Romans, that the things that are made point to a creator. And yet it's interesting that it wasn't until Revelation that the idea of a creator God emerged. I agree with what you were saying, but I just think that's an interesting thing to reflect on. Perhaps we'll have some interesting conversations about that and other matters over the break. So, Book of Wisdom.
I think the Book of Wisdom has a lot more metaphysics in it than people realize. Benedict pointed out that this Hellenization was going on before the New Testament and before,
Uh-huh.
The Book of Wisdom has lots of profound metaphysics. And I
Well, I think it does too. But thank you so much. We appreciated it.